The world runs on invisible technology. Billions of transistors, each one smaller than a human cell, power everything from the smartphone in your pocket to the satellites orbiting overhead. These microscopic marvels enable artificial intelligence, connect our cities, drive our vehicles, and underpin national defense systems. Yet most people have never heard of the companies that make this possible. Today we're examining a critical turning point in the global technology landscape, one that could determine which nations lead the digital age and which, honestly, might fall behind. At the center of this drama stands a Dutch company whose machines are so advanced, so irreplaceable, that governments worldwide are treating them as strategic weapons. We're talking about the semiconductor industry's hidden kingmaker, ASML, and its European counterpart, NXP Semiconductors. This isn't a typical business story. This is about technological sovereignty, geopolitical chess moves, and the quiet battle being waged over who controls the infrastructure of our digital future. The decisions being made right now in boardrooms in Eindhoven and government offices across Europe will ripple through every connected device on the planet. Let's understand why chips have become the new oil, why Europe is making its stand, and what this means for the technology in your daily life. Chapter 1: The Unexpected Player in a High-Stakes Game. Picture this: a semiconductor company headquartered not in Silicon Valley, not in Seoul or Taipei, but in Eindhoven, Netherlands. NXP Semiconductors doesn't manufacture the processors that grab headlines in tech reviews. Instead, it produces the specialized chips that make modern life function, the microcontrollers in your car's safety systems, the secure elements in your credit card, the radio frequency chips enabling contactless payments. In December of last year, NXP completed a massive $12 billion acquisition of Freescale Semiconductor, instantly transforming itself into one of the industry's most formidable specialized players. This wasn't a vanity purchase or empire building, it was strategic consolidation in a market where scale and specialization determine survival. The combined entity emerged as the world's leading automotive semiconductor manufacturer, a position of enormous significance as vehicles evolve from mechanical machines into rolling computers. Modern cars contain hundreds of chips managing everything from engine performance to collision avoidance, from entertainment systems to advanced driver assistance features that can literally mean the difference between life and death. NXP's technology portfolio extends far beyond automotive applications. The company pioneered near-field communication technology, the innovation enabling Apple Pay and countless other contactless transaction systems. They produce the EMV chips embedded in credit cards worldwide, adding crucial security layers to billions of daily transactions. In the expanding Internet of Things ecosystem, where everyday objects gain connectivity and intelligence, NXP's chips provide the essential connectivity and processing power. When the company reported quarterly earnings recently, the numbers told a story of momentum. They exceeded profit expectations by 5 cents per share, delivered on a base of $1.09, with revenues slightly above analyst predictions. Perhaps most impressive was their gross margin expansion, the percentage of revenue remaining after manufacturing costs, which grew by 150 basis points year over year. In the capital-intensive, margin-sensitive semiconductor business, this kind of improvement signals operational excellence and pricing power. Management indicated the Freescale integration was proceeding smoothly, always a critical concern with acquisitions of this magnitude, where cultural clashes and operational complexity can destroy value quickly. The market responded enthusiastically. The stock climbed from $83 before the earnings announcement to nearly $89 following the report. Then came the pullback. After the company's annual Analyst Day presentation, shares retreated to $86, a decline of roughly 3.5%. For context, this followed months of strong performance since the broader market bottom in February. The retreat wasn't driven by fundamental deterioration, but rather by investors digesting the company's long-term outlook and recalibrating expectations. Yet, to understand NXP's true significance, we must zoom out from quarterly results and stock price movements to examine the company's role in a much larger drama: Europe's fight for technological relevance in an increasingly polarized global landscape. Chapter 2: The Looming Crisis of Chip Sovereignty. Semiconductors have become the physical manifestation of geopolitical power. Nations are investing hundreds of billions of dollars to secure domestic chip production capabilities, not out of economic efficiency, but strategic necessity. The ability to produce advanced semiconductors increasingly determines military capability, economic competitiveness, and technological independence. The landscape is dominated by two regions: Asia and North America. Taiwan Semiconductor Manufacturing Company produces the world's most advanced chips, fabricating processors for Apple, NVIDIA, AMD, and countless others. Samsung in South Korea runs a close second. Intel, despite recent struggles, remains America's semiconductor flagship. Chinese companies, backed by enormous state investment, are racing to achieve self-sufficiency despite Western technology restrictions. Europe, despite being home to some of the world's most sophisticated economies, holds only about 10% of global semiconductor production capacity. This dependence creates vulnerability: economic, strategic, and political. European automotive manufacturers, industrial equipment producers, and technology companies rely on semiconductor supply chains where they exercise minimal control. The global chip shortage that emerged during the pandemic illuminated this vulnerability painfully. Automobile production lines sat idle for months awaiting chips worth mere dollars per unit, while manufacturers lost billions in foregone sales. Consumer electronics faced similar constraints. The shortage wasn't primarily about production capacity. It exposed how concentrated and fragile semiconductor supply chains had become. For Europe, this created an existential question: can a modern economy remain competitive, secure, and sovereign while depending almost entirely on foreign semiconductor production? The answer increasingly appears to be no, which explains why European policymakers are treating chip production as a strategic priority, comparable to energy security or food supply. But Europe faces a dilemma. It cannot realistically compete with Asian foundries in mass production of cutting-edge logic chips. TSMC's scale, accumulated expertise, and Taiwanese government support create advantages that would require decades and hundreds of billions of euros to replicate. Simply trying to match Asian production capacity would be economically irrational and strategically impossible. Instead, Europe is pursuing a different path, dominating niches where European companies already hold advantages. Automotive semiconductors, where reliability and safety certification matter more than bleeding-edge performance. Industrial chips built to withstand extreme environments. Security-focused microcontrollers where trusted design and manufacturing matter enormously. Power management semiconductors. Sensor systems. This is where NXP's importance becomes clear. The company embodies Europe's semiconductor strategy: specialized, high-value chips where design expertise, customer relationships, and application knowledge create defensible competitive positions. NXP doesn't need to manufacture 3-nanometer chips that become obsolete in 2 years. It produces chips with longer life cycles, higher margins, and critical importance to customers who value reliability over raw performance. The blurring of commercial and strategic interests in semiconductors is nowhere more evident than in the saga of Nexperia, a company with direct lineage to NXP. Nexperia was originally part of NXP before being sold to Chinese investors. The company specializes in discrete semiconductors, logic chips, and MOSFETs, unglamorous but essential components found in virtually all electronic devices. For years, the ownership arrangement functioned normally, with Nexperia operating facilities including a strategically important fab in Newport, Wales. Then, geopolitical winds shifted. As Western governments grew increasingly concerned about Chinese access to critical technologies, regulators began scrutinizing transactions that would have previously passed unnoticed. The Dutch government, under pressure from allies and concerned about technological dependencies, intervened in NXP's operations, imposing restrictions on technology transfer and questioning whether Chinese ownership of semiconductor assets on European soil aligned with national security interests. This wasn't theoretical paranoia. Semiconductors increasingly underpin military systems, critical infrastructure, and national security capabilities. Advanced chips power everything from encrypted communications to targeting systems, from cyber warfare tools to intelligence-gathering platforms. A nation that controls chip design or manufacturing potentially gains insight into, or leverage over, the technologies depending on those chips. The intervention sent unmistakable signals. Europe would no longer treat semiconductor companies as purely commercial entities. Strategic chips require strategic oversight, even when this conflicts with free market principles or international investment flows. For NXP, despite being separated from Nexperia, the message was clear. As Europe's premier semiconductor company, it occupies a position of strategic importance extending well beyond shareholder returns. The chips it designs and the technologies it develops are European assets, requiring protection and cultivation like any critical national resource. To truly understand Europe's semiconductor position, we must examine ASML, the Dutch company whose machines make advanced chip manufacturing possible. ASML produces extreme ultraviolet lithography systems, extraordinarily complex machines that use light with wavelengths measured in nanometers to etch transistor patterns onto silicon wafers. These aren't merely sophisticated manufacturing equipment. They represent the absolute pinnacle of human engineering achievement, containing hundreds of thousands of components, requiring mirrors polished to atomic precision, and costing upwards of $150 million per unit. Here's the critical fact. ASML holds a global monopoly on EUV lithography. Every cutting-edge chip fab worldwide, whether operated by TSMC, Samsung, or Intel, depends entirely on ASML machines to produce their most advanced semiconductors. There is no alternative supplier. No competitor is even close to matching ASML's capabilities. This gives the Netherlands, and by extension Europe, extraordinary leverage in the global semiconductor ecosystem. While Europe may not dominate chip manufacturing, it controls the choke point technology that makes advanced manufacturing possible. This is power. Subtle, technical, but absolute. For years, ASML sold its machines to qualified buyers worldwide with minimal restrictions, treating them as commercial products governed by normal export regulations. But as geopolitical tensions escalated, particularly between the West and China, pressure mounted on the Dutch government to treat ASML's technology as the strategic asset it truly represents. In 2023, the Netherlands introduced licensing requirements for the most advanced lithography systems, effectively requiring government approval before selling cutting-edge equipment to certain customers. By 2024 and into 2025, these restrictions expanded significantly, covering not just the latest EUV systems, but also older deep ultraviolet lithography tools, inspection equipment, and metrology devices that measure microscopic features on chips. The expansion is significant. While EUV systems enable the most advanced chips, DUV equipment remains essential for producing the vast majority of semiconductors, including many chips used in automotive, industrial, and consumer applications. By extending export controls to these older but still sophisticated systems, the Dutch government effectively tightened its grip over global semiconductor manufacturing capacity. The stated rationale is national security. Advanced semiconductors can enhance military capabilities, enable surveillance technologies, power AI systems with dual-use applications, and strengthen cyber warfare capabilities. By controlling access to the tools that manufacture these chips, The Netherlands aims to prevent technology diffusion that could shift geopolitical balances. But there's also an economic calculation. By treating lithography equipment as strategic rather than purely commercial, Europe maintains leverage in negotiations over technology access, intellectual property protection, and reciprocal market access. Make no mistake, we are witnessing the early stages of technological bifurcation, where the global economy splits into competing technological ecosystems with limited interoperability and mutual dependence. The United States has led this charge, implementing extensive export controls, restricting Chinese access to advanced chips and the equipment to manufacture them. The CHIPS Act committed over $50 billion to rebuild American semiconductor manufacturing, explicitly framed as a national security imperative. American pressure on allies like the Netherlands, Japan, and South Korea to align their export policies has been sustained and increasingly successful. China, facing these restrictions, has responded with massive investment in indigenous semiconductor capabilities. Despite technological obstacles and significant quality gaps, Chinese fabs are improving rapidly, learning to work around Western technology restrictions and making progress that repeatedly surprises outside observers who underestimated their determination and resourcefulness. Europe finds itself caught between these titans, with interests that don't align perfectly with either. European companies need access to Chinese markets. China remains the world's largest semiconductor consumer and a critical customer for companies like NXP and ASML. But Europe also recognizes strategic alignment with the United States and shares concerns about technology transfer to potential adversaries. The Dutch export controls represent Europe attempting to chart its own course, aligned with Western strategic interests but implemented on European terms and timelines. The controls are tighter than pure commercial logic would suggest, but less severe than America might prefer, reflecting Dutch and European interests in maintaining some Chinese market access, while demonstrating commitment to technology security. For NXP, these dynamics create both challenge and opportunity. The company's global customer base includes Chinese manufacturers who may face restricted access to the most advanced production equipment. This could limit NXP's growth in certain segments. However, it also positions NXP as a trusted supplier of chips manufactured with European oversight, potentially advantageous as customers diversify supply chains away from geopolitically risky sources. If you're sitting there thinking, I don't work in semiconductors, why should I care about Dutch export policy? Well, just consider how thoroughly chips have become woven into modern life. Your smartphone, for instance, contains dozens of specialized chips beyond just the main processor. There are radio frequency chips managing your wireless connections, power management chips optimizing battery life, security chips protecting your data, sensor chips enabling those camera features, and audio chips processing sound. Now, if there's a supply constraint or a price increase in any of these components, the effects ripple through the entire device ecosystem. And if you've got a recently manufactured automobile, it likely contains hundreds of semiconductor components, managing everything from engine performance and safety systems to entertainment, navigation, and emissions control. The global chip shortage really showed us how a shortage of relatively inexpensive components could actually halt production of vehicles worth tens of thousands of dollars. The infrastructure that supports modern life, things like power grids, telecommunications networks, financial systems, healthcare facilities, and transportation logistics, depends entirely on semiconductor-enabled systems. Disruptions to chip supply chains can create vulnerabilities across entire economies. Now, export restrictions on semiconductor manufacturing equipment have several very real impacts. First, there's supply uncertainty. Chip fabs relying on equipment from restricted sources could face production disruptions if they're unable to get the necessary tools or replacement parts. Then, there are price pressures. When supply is constrained and demand stays strong, prices usually go up, and those costs eventually reach you and me through more expensive devices. Innovation can also get delayed. Cutting-edge technologies from advanced AI to autonomous vehicles to next-generation medical devices all depend on improvements in semiconductors. Anything that slows chip advancement slows broader technological progress. And let's not forget geopolitical instability. Technology competition between major powers creates unpredictability in international relations, trade policies, and economic cooperation. For professionals working in technology, automotive, industrial, or consumer electronics sectors, semiconductor supply chain dynamics directly affect business planning, product development timelines, and competitive positioning. Europe's semiconductor strategy is really a calculated bet that specialized expertise can stand in for sheer manufacturing scale. The European Union recently announced the CHIPS Act, committing over 43 billion euros to semiconductor research, development, and production capacity. But this isn't about matching Asian or American investment levels. It's targeted spending, focused on strengthening areas where Europe already has an edge. For example, NXP received a €1 billion loan from the European Investment Bank, specifically to expand R&D and production capabilities in strategic semiconductor segments. This isn't just corporate welfare, it's a strategic investment in capabilities that European policymakers see as absolutely critical to economic security. NXP's focus areas line up perfectly with European strategic priorities. In automotive semiconductors, Europe is home to major automotive manufacturers who are increasingly viewing secure, reliable chip supply as existential. NXP's position as the leading automotive chip supplier makes it indispensable to this ecosystem. When it comes to secure microcontrollers, as digital security becomes absolutely paramount for financial transactions, identity verification, IoT devices, and critical infrastructure, chips designed with security as a foundational requirement become even more valuable. NXP's decades of experience in secure chip design really create defensible competitive advantages. In industrial semiconductors, European manufacturing excellence depends on sophisticated industrial equipment that requires specialized chips able to tolerate harsh environments, extreme temperatures, and demanding reliability requirements. And with IoT connectivity, as everyday objects gain network connectivity and embedded intelligence, the chips enabling this connectivity are becoming ubiquitous. NXP's expertise in low-power wireless communication puts it in a strong position for this expanding market. Now, these aren't the most glamorous semiconductor segments. Those headlines usually go to cutting-edge AI accelerators and smartphone processors. But these segments represent enormous, growing markets where performance isn't measured purely in processing speed, but in reliability, security, longevity, and specialized functionality. Looking forward, there are several possible scenarios, each with dramatically different implications. Let's start with Scenario 1, accelerated decoupling. Here, geopolitical tensions keep escalating, export controls expand further, covering more technologies and applications. China responds by accelerating domestic semiconductor development, accepting short-term quality and performance gaps for long-term independence. Global semiconductor supply chains fracture into Western and Chinese ecosystems with minimal overlap. In this situation, NXP and other European companies must make a choice: align primarily with Western markets and accept losing Chinese market share, or try to straddle both worlds, which gets harder by the day. European governments would likely pressure companies toward Western alignment, possibly compensating for lost Chinese revenue through subsidies or guaranteed domestic demand. Scenario 2 is selective cooperation. In this case, current tensions stabilize at a new equilibrium. Export controls focus narrowly on genuinely sensitive military and surveillance applications, while commercial technology trade continues with appropriate safeguards. China makes enough progress in indigenous semiconductors to reduce its most critical dependencies, but still imports where Western technology offers real advantages. Here, NXP benefits from being European rather than American. potentially seen as a less geopolitically fraught supplier by Chinese customers, while still maintaining credibility with Western partners. The company could serve as a bridge, benefiting from diversified revenue streams across geopolitical blocs. Scenario 3 is European leadership emergence. Europe successfully leverages its strengths in specialized semiconductors, a monopoly in lithography equipment, and automotive and industrial expertise to carve out a distinctive position. Companies like NXP become preferred suppliers for applications where reliability, security, and trusted supply chains matter more than just cutting-edge performance. European chip production capacity expands meaningfully, but in a strategic way, not trying to match Asian scale in commodity chips, but focusing on high-value specialized segments. This would see Europe establishing real technological sovereignty in certain domains while accepting dependence in others. And finally, Scenario 4. Technological surprise. Here, China's semiconductor programs achieve an unexpected breakthrough, developing advanced lithography alternatives or novel chip architectures that bypass current technological choke points. Western export controls lose effectiveness as Chinese companies show they can produce competitive chips with indigenous equipment. This would fundamentally reshape global semiconductor dynamics, possibly triggering even more aggressive Western technology controls, or, conversely, forcing a recognition that technological containment has failed. For NXP, this could mean intensified competition from Chinese rivals who previously lacked access to necessary manufacturing capabilities. Often lost in all the geopolitical analysis and corporate strategy discussions are the engineers, workers, and communities whose livelihoods depend on decisions made in the semiconductor industry. ASML, for instance, employs tens of thousands of highly skilled workers in the Netherlands and around the world. Export restrictions mean that some of their most sophisticated machines can no longer be sold to previously important customers, which could affect production volumes, employment levels, and the company's long-term investment plans. NXP's workforce spans multiple countries and specializes in application-specific chip design, a field that requires years to develop true expertise. Geopolitical disruptions to supply chains or customer relationships create a level of uncertainty that makes long-term workforce planning really difficult. And on the other side, Chinese semiconductor workers face their own challenges. Intense pressure to achieve technological breakthroughs despite equipment limitations, working for companies that might suddenly lose access to critical foreign technologies, and navigating careers in an industry that's increasingly defined by geopolitics rather than just technical or commercial considerations.